All right, so continuing with systems of equations, solving systems of equations by using elimination, we are on level 2, which means that we're going to have to multiply one of our equations in order to be able to eliminate something. So I have the equation x minus 6y equals 1, and then the equation 4x minus 5y equals 23. Now, as you can see here, I don't have, well, my equations, first of all, step 1 is done. They're already stacked up right above their like terms. So step 1 is done. Step 2 is to find opposites or create them if I don't have any. And so as you can see here, I don't have any opposites. I have 1x and 4x. Those are not opposites. And then I have negative 6y and negative 5y. Those also are not opposites. So what I'm going to do is I'm going to have to figure out what do I need to multiply these equations by so that I can end up with opposites. So if I look at 1 and 4 and 6 and 5, I'm just going to ask myself, what would I rather work with, 1 and 4 or 6 and 5? I would rather work with 1 and 4. So I'm going to work on eliminating x. The reason why I chose 1 and 4 is just because they're smaller numbers. If you choose, you can go ahead and work on eliminating y, and you would end up with the same answer. So because these are not opposites, I need to multiply one of these equations so that they are opposites. So I'm going to find the least common multiples of 1 and 4. So first for 1. Least common multiples of 1. Well, 1 times 1 is 1. 1 times 2 is 2. 1 times 3 is 3. 1 times 4 is 4. And 1 times 5 is 5. Okay. Now I'm going to find the multiples of 4. 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. And I'm going to stop there. Do they have any in common? Yes, they do. And so I want the smallest number that they have in common. The smallest number that they have in common is 4. So I know that I can turn one of these equations, I can multiply one of these equations by something so that it ends up being 4. Okay, now I already have a positive 4x here in the bottom. So instead of making this a positive 4 and multiplying by 4, I'm actually going to multiply by negative 4. Well, how do we know to multiply by negative 4? Well, because remember, you want opposites, right? If I just multiply by a positive 4, this is going to become 4x, and this is already 4x. So those are not opposites. I need to multiply by a negative 4 so that I end up with negative 4x. So we're going to go ahead and multiply this entire equation by negative 4. Negative 4 times 1x is negative 4x. Negative 4 times negative 6y is positive 24y. And then negative 4 times 1 is negative 4. And then the second equation, I didn't multiply by anything. I didn't change it at all. So I'm just going to copy it right back down here so that, remember, they're stacked up so that it's nice and easy to add these together. So now that I have opposites, my opposites are shown here, negative 4x and positive 4x. I'm going to go ahead and add these equations together. And when I add these, my opposites cancel out. Negative 4x plus 4x is 0. 24y minus 5y is 19y. And then negative 4 plus 23 is 19. Okay, so from there, I'm going to go ahead and solve for y. So I'm going to divide both sides by 19. And 19 divided by 19 is 1. So y equals 1. Okay, continuing on with step 4 now. I found out that y equals 1. So step 4 says that I can go ahead and substitute that into one of my original equations. So I'm going to write down the top equation. I want to use the top equation because the numbers look smaller and easier to deal with. So that's what I'm going to do. And so since I now know y equals 1, I'm going to replace the y here, x minus 6 times, so instead of y, I'm going to replace that y with a 1 because I know y equals 1. So then I'm left with x minus 6 times 1 is 6 equals positive 1. And I'm going to go ahead and solve. So I'm going to add 6 to both sides. I'm left with x equals 7. So my solution to this system of equations is 7, comma 1. Final answer. All right, so next question, 7, x plus y equals negative 3, and then 8x minus 5y equals 2. Go ahead and try this one on your own, and then let me know what you get. Moving on to level 3. So level 3 takes it up a notch in that now I'm going to have to multiply 2 times. I'm going to have to multiply both of my equations by something in order to get opposite terms for step 2. So I have the equation 2x plus 3y equals 2, and then the equation 3x plus 5y equals 7. So they're already stacked. That's step 1. Step 2 is to find or create opposite terms. So I want to find, again, the least common multiple between my variable terms, whichever one you choose to work with. So for x, for example, I have 2x and 3x. And for y, I have 3y and 5y. So you can choose to work with whatever you want. I would prefer to work with 2 and 3 because they're smaller numbers. So multiples of 2, 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. And 2 times 4 is 8. Let's go that far. And then multiples of 3, because that other, the bottom equation has a 3 as the coefficient with x. So 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. And I can stop here because I already identified the least common multiple, which is 6. So I need to go ahead and turn that x term into a term that has a coefficient of 6. So for the top equation, for example, I can multiply 2 times 3 to get 6. So I'm going to multiply the top equation by 3. In the bottom, what do I multiply 3 by to get 6? I can multiply 3 by 2 to get 6. But remember, if I multiply 3 times 2, that's a positive 6. If I multiply 2 times 3, that's also a positive 6. So I want one of these to be negative. I'm going to make the bottom one negative 2. So let's go ahead and do that. Multiplying here, 3 times 2x is 6x. 3 times 3y is positive 9y. And 3 times 2 is positive 6. Repeating the same thing here in the bottom. Negative 2 times 3x is negative 6x. Negative 2 times 5y is negative 10y. And then negative 2 times 7 is negative 14. Now I have opposite terms. My opposite terms here are 6x and negative 6x. When I add those, I'm going to get 0. So let's go ahead and add our equations. 9y plus negative 10y is negative 1y, or negative y, equals 6 plus negative 14, which is negative 8. And now to get that y completely by itself, I'm going to divide both sides by negative 1. So I'm left with y equals positive 8. Okay, so that's step 3. You add your equations together and you solve for that term. Now that I know y equals 8, I can go ahead and choose one of my original equations. I'm going to choose the top one here, 2x plus 3y equals 2, just because the numbers are smaller. And instead of y, I'm going to go ahead and substitute 8 in for y. So this becomes 2x plus 3 multiplied by 8. Oops. Equals 2. All right, so again, 2x plus 3 times 8 is 24 equals 2. And I'm going to go ahead and solve this two-step equation. I'm going to subtract 24 on both sides. My goal is to get x by itself. And I'll be left with 2x equals negative 22. To solve this, I'm going to divide by 2 on both sides. I'm left with x equals negative 11. So my solution here, my ordered pair, is negative 11, comma 8. Okay, moving on to number 9. Number 9, we have 4x minus 3y equals negative 5. 3x plus 4y equals 15. So again here, we're going to need we're going to need to multiply both of these equations, right? Because none of these are the same. 4x and 3x are not they don't have the same coefficient and they don't have opposite signs. So they're not inverses. Negative 3y and positive 4y are also not inverses. So let's go ahead and start with one. In this case, you can eliminate whichever one you want. I'm just going to eliminate the y's here because I haven't eliminated y's. So I'm just going to do it that way, but you can do whichever one you want. So first of all, I'm going to write the multiples of 3. Actually, it's better here to eliminate y's because the signs are already different. So you don't got to worry about the signs. You just got to worry about the coefficient. So multiples of 3 are 3, 6, 9, 12, 15. Multiples of 4 are 4, 8, 12, 16. And as you can see here, right, 12 is the least common multiple. It's the smallest number that they have in common. So I'm going to multiply the top equation. I want to turn that negative 3 into a negative 12. So to turn this negative 3 into negative 12, I'm going to multiply the top equation by 4. And then the bottom, I'm going to multiply. I want to turn that positive 4y into a positive 12y. So I'm going to multiply that by 3. So this equation here, 4 times 4x is 16x. 4 times negative 3y is negative 12y. And 4 times negative 5 is negative 20. Then this bottom equation, 3 times 3x is 9x. 3 times 4y is positive 12y. And then 3 times 15 is 45. Now I have opposite terms, right? Negative 12y and positive 12y are opposite. So when I add them together, I get 0. And then over here, 16x plus 9x is 25x. And then negative 20 plus 45 is 25. To get x by itself, I'm going to go ahead and divide both sides by 25. I'm left with x equals 1. Now that I know x equals 1, I can choose either of those equations. I'm going to choose the second one, 3x plus 4y equals 15. The reason why is because they're all positive numbers, and I'd rather deal with an equation that's all positive. So wherever I see an x, I'm going to replace that with a 1. 3 times 1 plus 4y equals 15. 3 times 1 is 3. Plus 4y equals 15. And then you go ahead and solve this equation by subtracting 3 on both sides. 3 minus 3 is 0. Drop down the 4y equals 15 minus 3, which is 12. So my final answer here, y equals 3, which means that the solution to this system of equations is 1, 3. That's my final answer. All right. Moving on to number 10. So this is the last one we'll do together. And then the final one, you will try that one on your own. So number 10, I have the equations negative 4x minus 8y equals negative 4. And then 3x plus 6y equals 3. Again, there's no opposites here. They don't have anything in common. You can decide which variable you want to eliminate. I'm going to eliminate the x terms because they're smaller numbers and they're already opposite signs. So negative 4x and then a positive 3x. I want to find the least common multiple. I think we already found the least common multiples between these. Oh, what happened? It's not letting me go back. Okay, here we go. All right, technical difficulties. So we've already found the least common multiples between negative 4 and 3, but just in case you didn't get it, multiples of negative 4, or let's just do multiples of 4, right? 4, it's 4, 8, 12, 16. And I'm going to stop there. Multiples of 3 are 3, 6, 9, 12. And there we go. I found what they have in common. They have 12 in common. So I'm going to multiply my top equation by 3 so that negative 4x becomes a negative 12x. And I'm going to multiply the bottom equation by 4 so that positive 3x becomes a positive 12x. So 3 times negative 4x is negative 12x. 3 times negative 8y is negative 24y. And then 3 times negative 4 is negative 12. And then here in the bottom, I have 4 times 3x, which is 12x. 4 times 6y, which is positive 24y. And then 4 times 3, which is positive 12. So that is step 2. I turned these equations. I created opposite terms. Those opposite terms are here, negative 12x and positive 12x, which is 0. But look what also happened. These are also opposite terms, negative 24y and positive 24y. So on this side, I have nothing. I have 0 equals negative 12 plus 12. Well, that's also 0. 0 equals 0. This is a true statement. And so because I get the same thing on both sides, that means that this solution here has infinitely many solutions. I'm sorry, this system of equation has infinitely many solutions. So anytime you end up with the exact same thing on both sides, 0 equals 0, for example, then that means that you have infinite solutions. All right, go ahead and try the last example on your own and let me know what you get. If you need any help, please see me after class. And that's it for solving systems of equations by using elimination.